Hi, my name is Barbara and I am a researcher studying rockfalls at University of Ljubljana. Together with my co-workers Francesca and Chris, we will present you a new and innovative toolbox called Protective Forest Assessment Tool that has been developed within the Interreg Alpine-Space project called Green Risk for Alps. We will guide you through the modeling process of the Protective Forest Assessment Tool and will explain to you its functionalities. Before we begin with the modeling process, let's go through basic layout of the web platform. Protective Forest Assessment Tool can be used in 5 languages: English, French, German, Italian, and Slovenian. To switch between the languages, go to the upper right side of the web platform and click on the flag icon. To overview the modeling steps of the Protective Forest Assessment Tool, move your mouse to the upper left side of the page and a window with all steps will appear. Once you will begin with modeling, you will be able to return to previous steps by clicking on the one you want to return to. In the middle of the welcome page, you can find a link to the tutorial video and link to the home page of the Green Risk for Alps project. More about the project and about the functionality of the Protective Forest Assessment Tool, please read the content in the lower section of the welcome page and visit the external links that are provided there. Now that we overviewed all the main features of the web page, let's begin with the modeling process by clicking on Start button, which is located in the middle of the welcome page. In the first step of the model, we have to select the natural hazard. With Protective Forest Assessment Tool, 3 types of natural hazards can be modeled: avalanches, rockfalls, and shallow landslides. If you move your mouse on the icon of the preferred hazard, a description of it will appear in lower section of the page. In this tutorial video, we will model avalanches, therefore we're going to click on the avalanche icon. By clicking on it, we will automatically be redirected to the next step of the model. Now we are located in the step in which we have to define the profile of the avalanche we are going to model. This can be done in 2 ways. The profile can be drawn on the map that is provided on this page, or it can be uploaded separately as a text file. The avalanche profile path must start at or just above the release area and extend well past the expected runout area. When drawing the profile on the map, you can zoom in or out by using a mouse wheel or by using plus or minus icon in the upper corner of the map. To start drawing the profile, click on the preferred location on the map and drag it to the end of the runout area. With the double click, you will end the drawing process. By clicking on the load button, the profile will be uploaded to the model. If you want to delete or change the profile, click on the button Clear and then draw the profile again. If you will import your own profile, as we will do in this video, you will have to obtain data about the length and elevation of that profile, and you must structure it into 2 columns: distance X column and elevation Z column. The data must be saved in a text or TCV format. Avalanche path used in this video is located in Oberammergau in Germany and was drawn and exported via GIS software. When the path is uploaded correctly, a green check mark should pop up. In the left corner under the map, you will see that additional information must be provided about the avalanche path. Firstly, you have to select the country in which the profile is located, in our case in Germany. Based on the country, the estimated costs for different protective measures will be adjusted according to the regional differences. If you don't choose any country, average values will be used. Then you also have to define the avalanche mean hazard path width in meters. To continue with modeling, click on the Next. The next step will lead you to define forest and infrastructure information.
Hi, I'm Francesca and I work in the economic unit of the Department of Agricultural, Forest and Food Sciences of the University of Turin. And now I will explain how to input the economic data into the model. The selected slope is affected by avalanches and is covered by a coniferous forest. Therefore, it's an area in which the forest could potentially play an important role against the hazard. The parameters we need to input in order to run the model refer mainly to the forest cover and the infrastructures present in that area. The forest can be added by clicking on the Add button on the right, and it can also be removed by clicking the Remove button. The same goes also for adding buildings and linear infrastructures. Like I've said before, the forest in that area is composed mainly by coniferous species. And given its good structures, we've given a forest structure index of 0.85 out of 1. The forest structure index is an estimate of the structure of the forest, and it ranges from 0 to 1, in which 1 would be the best structured protection forest against the natural hazard, while 0 would be something like a grass field that's totally useless against the natural hazard considered. The forest starts at the beginning of the slope and ends at 450 meters along the profile. To measure the position of the forest along the profile, the user can either measure it using a GIS software or more easily using Google Maps or Google Earth. At the base of the slope there's a NATO school, and this school is composed by different infrastructures, among which there's a road and different buildings. As for the infrastructures, we have two main categories: linear infrastructures and buildings. The linear infrastructures can be either forest roads, primary roads, secondary roads, railways or power lines. In this case, we just have one road, that's a secondary road, and it has a pretty low traffic intensity because it's a private road. Its value is of about 250 euro per meter, and it has a length of about 100 meters. In this case, we don't have a detour that can be taken to avoid the road, and so the detour value is 0, and the location of the road is at 520 meters along the profile. Finally, we have the buildings. In this study case, we just have public buildings because they are part of a school. Also, the dimension of the building can be found on measuring it on Google Maps or Google Earth. The number of people per building can also be estimated, and we estimated it according to the number of seats in the building. Next, Barbara will introduce how to pick which mitigation measure to consider.
In the following step, you can choose which mitigation measures you want to consider in economic analysis in comparison to the protective forest. You can choose between green, technical, and avoidance measures. Each measures are adapted to the hazard you have chosen to model. By clicking on each group, different measures will appear. By moving your mouse on the info button on the left side of individual measure's name, you will get a detailed explanation of what this measure represents. When you click on the button on the right side of the measure, you will include it to the model. Afterwards, additional content will appear and you will have to define different attributes. From green measures, you can choose either forest rehabilitation or afforestation. For example, for forest rehabilitation, you will have to define the part of the profile with forest where additional measures will be taken, information on the forest type, and information on rehabilitation costs. With afforestation, you will have to define the part of the profile where afforestation should be done, choose the forest type, and define the hazard's release area. These measures are the same for avalanches and rockfalls, while for shallow landslides you can only choose afforestation. Technical measures are not available for shallow landslides, while for avalanches you can choose steel snow bridges and avalanche catching dams, and for rockfalls you can choose rockfall nets. Additionally, with all technical measures, you have to select which infrastructure they are going to protect. The last group of measures are avoidance measures. With all hazards, you can choose from road closure, building evacuation, early warning system, and building relocation. With avalanches, you can also choose artificial release. Once you have selected all mitigation measures, click on Calculate. If the button Calculate is not available for clicking, it will be in gray. This means you still have to select some attributes for the measures. In this case, please check if you put in everything correctly. When the button color changes to red, you will be able to click on it and continue. After that step, the results of the FAT model will appear.
This is how the final table looks like. For each measure selected, 4 economic parameters gets calculated, so we have direct cost, indirect cost, avoided damages and benefits. Instead of the values in euro, we decided to show the results graphically. So the values related to the money that need to be spent for a certain measure are represented with red coins, while the benefits are shown in green. The bigger the coin is, the higher the corresponding economic value is. The measures are ranked in terms of cost-benefit ratio, so the first ones on the list are supposed to be the most effective in terms of cost benefits. In this specific case, we can see that the highest ranked measures are road closure and building evacuations, and they are both avoidance measures. However, the measure with the highest benefits are technical measures like snow fences and avalanche catching dams. But they are ranked lower compared to the other measures because they have higher implementing costs. Finally, we can see how the forest in this study case isn't effective against an avalanche with an 100 years return period. In fact, in the table, only the costs are shown because the benefits are equal to 0.
Hello, my name's Christopher. I'm a data scientist and researcher at the Austrian Research Center on Forest. I mainly focus on snow and avalanches and protection forests. I am going to guide you through the graphical results of the hazard model. You should be familiar with this plot already. It shows the forest with the thick green line, the road with the gray X, and the buildings with the red boxes. Overlaid on this are the results of the hazard model. They are 2 lines. One is green and one is blue. They're hard to distinguish without zooming in. You can zoom in by using some of the graphical tools that pop up when you hover over the map. The green line represents the model run when forest is considered. The blue line represents the natural hazard model when the forest is not considered. The difference between these lines is outlined with the red line that's overlaid. This is the percent difference between these 2 lines. Essentially, this is the percent difference in the kinetic energy height of with and without forest. If you scroll down, there's a list of the mitigation measures that were considered during this model run. If you click on the checkbox to the right, it will turn red, and some extended results will open up. Here, you can see a lot of the calculations that were used to reach the values that are presented in the results table above. With this, you can really look at the different assumptions that were made and try to figure out how or why a particular mitigation measure was so expensive or so cheap.
You have successfully completed the calculation routine for selected hazard using the FAT tool. We thank you and encourage you to also use it in the future. please visit the Green Risk for Alps website. You can find the link in the video description. On the website, you will find more information about the methods used in FAT and natural hazards in alpine space. Hopefully, the FAT model will help you in assessing the value of protective forest in comparison to other mitigation measures in regards to avalanches, rockfalls, or shallow landslides.